Oops, sorry, my video paused there or stopped going. So here we go, keep going. So we're gonna move the 3 to the other side. So that gives me y plus 3 equals 2x minus 4 all squared. And I'm gonna multiply by 1/2 to both sides. Now I'm gonna take half to the right and a half to the entire left. So I'm gonna bracket that. So here we go, we have 1/2 y plus 3 equals x minus 4. Okay, that 1/2 means the y's are going to get doubled. This is for the vertex. That means the y part is at -3 and the x part is at +4. So the vertex is at 4, -3, and then the heights are getting doubled. Okay, 1, 2, 3, 4, 1, 2, 3. So right there's the vertex. Now I know I'm supposed to go over 1, up 1, over 1, up 1 like that. But the heights are getting doubled. So over 1, up 1 gets doubled. Over 1, up 1, the height gets doubled. Okay, then I'm supposed to go over 1, 2, and then up 1, 2, 3, 4 for the normal one. Over 2, up 4. So the red would be how wide a normal one would be. But this 4 height has got to get doubled. So instead of going over 2, up 4, I'm going over 2, up twice the height for up 8. 1, 2, 3, 4, 5, 6, 7, 8. Over 2, up 8. So we can already see that the black one is twice as tall as what the red one would have been. The red one would have, the next one for the red would have been 3, 9. 1, 2, 3, 4, 5, 6, 7, 8, 9. The red one would have been out there. And out there. So the red would be the normal height. The black is twice as tall. The black is the answer. Okay, so let's do that again. I'm going to move the 2 to the other side first. So I have y minus 2 equals 1/2 x minus 4 all squared. And now I'm going to multiply off this 1/2. I'm going to multiply both sides by 2. Because that 1/2 does not really belong to the x. It has not been captured. So my real problem is 2, y minus 2 equals x minus 4 all squared. Okay, here's the vertex. The y part is 2, the x part is 4. So there's the vertex, 2, 4. The y part is going to be a multiplier of 1/2. Okay, so start at 2, 4. Over 2, up 4. There's the vertex. It's going to be half as wide, though. So I'm supposed to go over 1, up 1, and over 1, up 1. So the red is the parent function, but I'm not. The y's are only going half as much. So instead of going over 1, instead of going up 1, I'm going to go up 1/2. So over 1, up 1/2, over 1, up 1/2. Okay, so that takes care of the 1, 1. The next one would be 2, 4. Supposed to go over 2, up 4. Okay, but the y's are half of that. So I'm supposed to go, if I was doing a normal red, over 2, up 4. 1, 2, 3, 4 would be way up there. Instead, I'm going to go over 2, up half as much. And over 2, up half as much. So it's right there. So that 1/2 right there meant it was going to go up half as much. But don't think about that. Move the things around and then just always do the inverse. Okay, this 1 belongs to the other side, and that negative also belongs to the other side. So first I'll go y subtract the 1. So I subtracted the 1. Now I'm going to multiply both sides times -1. So those two negatives cancel out. So we have -1 times y minus 1 equals x plus 4 all squared. So here's the vertex, 1 and -4. And then the y's are all going to get multiplied by -1 because -1 times -1 is a +1, and that's what multiple inverses are trying to force a +1, just like additive inverses of -1 and 1 are trying to force a 0. Okay, so our vertex, -4, 1, -4, 1. That's like the 0, 0. Next I need 1, 1. Well, the y part is getting multiplied by negative. So instead of going over 1, up 1, I'm going over 1, down 1. And instead of going over 2, up 4, the y part gets negated, so I'm going to go over 2, down 4. Okay, 17 and 18, these can go maybe a little bit quicker now. So first move the 3, so y plus 3 equals -4, x plus 1 all squared. And I'll multiply off, so I'm just trying to make the -4 cancel out. So I'm going to multiply by another negative, because a negative times a negative, I need a negative to cancel that out. So I'm going to multiply this side over here by -1/4. So we end up with -1/4 y plus 3 equals x plus 1 all squared. Okay, here's the vertex. Those two make a vertex. The x will be -1, the y will be -3. So there's the vertex. Okay, I need the multiplier has to force a +1 when multiplying. So all the y's are going to get multiplied by -4. That means it's 4 times taller, upside down. Okay, vertex, -1, -3. So okay, this is counting by 2's. So -1, -3 right there. Okay, I would go over 1, up 1, and over 1, up 1. So it would be right in there if it was normal. But it's going to be upside down times 4. So over 1, down 4. 1, 2, 3, 4. And over 1, down 4. 1, 2, 3, 4. So that takes care of the 1, 1. The 1, 1 became 1, -4. The next normal one would be 2, 4. Okay, well the y part's getting multiplied by 4, so that's going to be at 2, -16. So from the center, now I'm going to go over 2. 1, 2, and down 16. 2, 4, 6, 8, 10, 12, 14, 16. And then over 2, down 16. Move the 2. So we have y minus 2 equals -1/2 x minus 2 all squared. Multiply off, put the 1/2 where it belongs. It doesn't belong with the x's, it belongs with the y's. So I'm going to multiply by -2. So that means I multiply this side over here by -2. So -2 and 1/2 cancel out. So we have -2 y minus 2 equals x minus 2 all squared. A whole bunch of 2's, but they all do something different. Okay, the vertex. Vertex is going to be at 2, 2. This one's connected to the y, so that means the y's are going to be multiplied by -2, so twice as tall going down. So if I start at 2, 2, over 2, up 2. Okay, I should be going over 1, down 1, but it's twice as much, so over 1, down 2. So here I'm going the 1, 1, which is supposed to be 1, 1, is now 1, -2. What's supposed to be 2, 4, the y part gets negative doubled, so it's going to be going down 8. So from here I'm going to go over 2, down 8. 1, 2, 1, 2, 3, 4, 5, 6, 7, 8 down here. And then 1, 2, down 8. there's our parabola for that one. Okay, now the last four have x multipliers on them. So let's deal with that. The 2 goes over that way, so we have y plus 2 equals 3x minus 12 all squared. Okay, so now this time the 3 is part of the x, but the x term has to be clean. You can't have any number on the x term, so we're going to have to factor it out of there. So we have y plus 2 equals, now we do still need it all squared. The x still has to capture everything. The square is holding the 3 and the 12, so it's all got to be part of the x-axis. But we are going to divide out the 3 from this part so that the x can be clean. So I factor a 3 out of that, dividing a 3 out of that makes it 4. So see, the shift was not 12, the shift was really 4. Okay, so here's the vertex. That one and that one are the vertex. So we've got a vertex, x is positive 4, y is negative 2. This, the inverse of times 3, the x's are a third as wide. So we're going to go sideways only a third of what we normally would. Okay, so the vertex, 0, 0, that's going to be the 4, negative 2. So 4, negative 2. Now, the 1, 1. From this one, we would normally go over 1, up 1. We would usually go over 1, up 1. But I'm not going to because the x's are getting a thirded. So that first x is only a third as much. So I'm going to go over a third, up 1. So over a third, up 1 is right there. And go left third, up 1 is right there. Then my next parent would be 2, 4. But the x's are getting thirded. So it's 2/3, 4. So from the center over 2/3, 1, 2, 3, 4, and 2/3, 1, 2, 3, 4. Now since it's a third, I think I will go one more since third will make it nice and clean. But the x part gets third, 3 times the third now is 1, so I can go over 1 up 9, so over 1 up 1, 2, 3, 4, 5, 6, 7, 8, 9 right there, and over 1 up 9 right there. Okay, that's a 1/2 on that x right there. So first, let's deal with that second. Let's move the 4 over there first to get it started. So I've got y minus 4 equals 1/2 x minus 3 all squared. Now, just on a side note over here in a thought bubble, I want you to consider this. If you take 7 and divide it by 1/2, remember how you do that. That means 7 times 2 over 1. 7 divided by 1/2 is 14. It's just like how many half pieces are in 7? Well, there's 14 half pieces in 7. Okay, the reason I say that is because now we have to factor out this half right there so that the x variable can be clean. So I'm going to divide out a half. Factoring is dividing. I'm dividing a half out of this, leaves just the x. But now I need to divide a half out of 3. I have 3 and I'm dividing it by a half. 3 divided by a half is 6. There are 6 halves in 3. Okay, so that makes the vertex. So the vertex then is at positive 6, positive 4. And the inverse of a half, the x's are going to be times 2. This is going to be 2 times as wide. So I'm going to start at the 6, 4. Over 6, up 4. Starts right there. Okay, so 0, 0 stays 0, 0. Doesn't move. The vertex right there is not going to move. But then I'm supposed to go 1, 1. But the x is getting doubled, so I'm going to go 2, 1. 1, 2, 1, and 1, 2, 1. Then the next one would be 2, 4, but the x gets doubled. So doubling the x makes it 4, 4. So I'm going to go 1, 2, 3, 4, 1, 2, 3, 4, and 1, 2, 3, 4, 1, 2, 3, 4. So the last little piece is just to make sure you can divide out a fraction. Well, 21's got an even harder fraction, a 3/4. Okay, well first let's move the 5 over there. So I've got y minus 5 equals negative 3/4 x minus 3 all squared. Okay, so y minus 5 equals, now I need to keep everybody in the x squared. The square is carrying all of that. So I'm going to divide out negative 3/4. That leaves an x for the first term. So I'm dividing everything by negative 3/4. So I'm taking this negative 3, I'll forget about a negative, and a negative is going to make this a positive, so I don't have to worry about the net. I'm dividing a negative 3/4. So I have a negative 3, and I'm dividing a negative 3/4. Okay, well that's the same thing as negative 3 times 4/3 negative. Okay, well the 3's cancel out, the negatives cancel out, and it's positive 4. 3 divided by 3/4 is positive 4. Okay, that makes the vertex right here. The vertex is at negative 4 for the x and positive 5 for the y. Now, all of the x's are all getting multiplied by negative 4/3, because 3/4 times 4/3 equals 1. Multiplicative inverses have to make 1. So I'm starting here, negative 4, 5. So there's the negative 4, 5. Now I got to figure out what 1, 1 does. Over 1, up 1. Okay, well the x's are getting multiplied by negative 4/3. So negative 4/3, 1. So that means I'm going sideways, negative 1 1/3, up 1. So negative 1 1/3, up 1 is right there. Then the next one would be negative 1, 1. Well, negative 4/3 times a negative 1 will make it 4/3, 1. See how the left went to the right and the right went to the left? Whenever there's a negative on the square, it actually flips left to right, right to left. So it's just going to look like the normal parabola. Over 1 1/3, up 1. Okay, the next one would have been 2, 4. So the x times 2. So 2 times 4/3 is 8/3. So 8/3 is 2 2/3. I'm going sideways, 2 2/3, up 4. 1, 2 2/3, 1, 2, 3, 4. Over 1, 2 2/3, 1, 2, 3, 4. And right there it is. So that negative really had no impact, because it made the left wing go right and the right wing go left, so it really looks like what it would have been even without the negative. But it did affect the shift, so that negative had something to do. Okay, now we got all kinds of craziness on this one. First of all, let's move the 5. Okay, y minus 5 equals negative 2/3 times negative 2/3 x minus 2 all squared. Okay, this 2/3 is connected to the x. This 2/3 can go over to the y. Okay, so I'm going to multiply by negative 3/2 to make this one go away, which means I got to multiply this by negative 3/2. Okay, I'm just going to do them one step at a time. Those are gone. So for the y's, we've got negative 3/2 y minus 5 equals negative 2/3 x minus 2 all squared. So there's the y part of the vertex, and there's a y stretch. But now I've got to fix this. I can't have that 2/3 on there. So let me go negative 3/2 y minus 5. Okay, I'm going to take, it's all got to stay as part of the x package, but I want to divide a 2/3 out of that. So negative 2/3 divided by negative 2/3 just leaves an x. So what I have to do is take this negative 2 and divide it by negative 2/3. Negative 2 divided by negative 2/3. That's the same thing as negative 2 times negative 3/2. Okay, see how the 2's cancel out? And the negative cancel out? It's 3. When I take a negative 2 and divide it by a negative 2/3, I end up with positive 3. Okay, let's see what all the shifts are. The vertex should be easy. The vertex, the x is negative 3, and the y is positive 5. Okay, right here, the y's are going to get multiplied. Remember, I need the inverse has to go to a positive 1, so I need to multiply them by negative 2/3, because a negative times a negative is positive, and 3/2 times 2/3 makes 1. So all the y's, in effect, this is going to be turned upside down, and 2/3 as tall. Okay, for the x's, I need to make that go to positive 1. So it's going to be multiplied by a negative, and then a 3/2, because a negative times a negative is a positive, and 2/3 times 3/2 is 1. Okay, let's start at the vertex. Negative 3, 5. Negative 3, positive 5. Right there. Okay, that's kind of like the 0, 0. That's the starting point. So I should go 1, 1 from there. I should go over 1, up 1. But, okay, the x is getting multiplied by negative 3/2. So that x right there is negative 3/2. The y is getting multiplied by negative 2/3. So that's negative 2/3. So I can plot that. That's left 1.5, down 2/3. So from here, I'm going to go left 1.5, down about 2/3, right there. Now, I could probably generalize it. If I go left 1.5, down 2/3, I'm going to go right 1.5, down 2/3, but let's see where that comes from. So left 1, up 1 is the parent. Okay, but the x is getting multiplied by a negative 3/2, so 3/2. There's the right 1.5. And the y is getting multiplied by negative 2/3. So right 1.5, down 2/3. I'm going to get one more set of points, the 2, 4. Okay, should have been 2, 4, but the x is multiplying it by that. So I've got a 2 times a negative 3/2. See how that's negative 3? Okay, and then the y part, so the 4 has to get multiplied by this y part, negative 2/3. Okay, that's negative 8/3. Negative 2 and 2/3. So negative 3 sideways, 2 and 2/3 down. So 1, 2, 3 sideways, 1, 2 and 2/3 down. That would mean 1, 2, 3 sideways this way, 2 and 2/3 down.